There are the answers from Friday's assignment. You can see those. That shouldn't be that difficult. If you do have any questions, I can answer those during tutoring. That'd be a lot easier.
Are you gonna review one of those, or you're gonna go to the next day?
I'm going to go on to the next thing, really, more. You can see here 14 through, say, 31. The reason why I put in, like, say, 28, 29, 30, and 31 is because I want you to put more practice into, say, completing the square. I will admit that 29 and 31 are a lot harder than what I would probably make, because I like to do it when it's just like x squared, some number in front of the x, and then you can kind of complete the square from there. So you can kind of keep into the pattern. Otherwise, if it gets more difficult than that, I'd say do the quadratic formula, which is what we're going over today. So let's look at that. So today we're going to go over the quadratic formula. That's 5, 6. We're going to solve using the quadratic formula. We're going to classify roots using the discriminant. And we'll define all that. You should have seen this before. You did the quadratic formula in Algebra 1. Maybe not quite to the extent that we're going to. If you were in MMA and you were a senior, then you will have a, if you're in my MMA class, I had taught my kids, type it into the Inspire and give me a decimal answer. Well, I'm not going to just take the decimal answer. I'm going to expect more. So we're going to see how you can do this. What is the quadratic formula? Again, the quadratic formula is if ax squared plus bx plus c equals 0, which is the standard form of a quadratic equation, then you can do the x is equal to negative b, or opposite of b, plus and minus b squared minus 4 times a times c, all of that over to a. Okay, you've seen that before. Okay, the way I like to do it, when I see a problem, I generally will start off with what you'll see here. X, negative parentheses, plus minus parentheses squared, minus 4 times parentheses, 2 parentheses. Like, I try to put, instead of the letters, I'm putting all my blanks. Then all I got to do is plug in my numbers. But I usually start off with all those blanks first, then plug in my numbers. Not anymore. Okay. In MMA, I allowed y'all to say, just plug it in, give me a decimal answer. But I'm going to want a simplified radical answer. Okay, and that's one. There's some steps you could do with a calculator. And if you can see those, great. If you don't, well, yeah, I guess I'll make it harder for you. But in this point, I've already substituted in. I've got this problem. I've chosen my A, B, and C. I've substituted in. I could look at that and go, what's 10 squared? 100. What's 4 times 1 times 2?
8. Negative 8.
So I've got 100 minus 8, which is 92. So I've got negative 10 plus and minus square root of 92 over 2. Now I want y'all to simplify that radical. And when you simplify that, you're saying 2 times...
Well, what is that negative, sir? Oh, 92, right. Oh, never mind.
Okay. So I got 2 and 46. 46 can be further simplified to 2 and 23. 23 is a prime number. So I've got a pair of what? Pair of 2s. That would go on the outside. What's left over stays inside. So I would end up with negative 10 plus and minus 2 square root of 23, all of that over 2. Okay. Now, this means divide again. But this 2 does not divide into just the 10. It divides into both the 10 and the 2. Anything that's outside. Inside the square root, never. Whatever's out here or under here cannot divide into the square root, ever. Okay. So what's negative 10 divided by 2? Negative 5. What's 2 divided by 2? So my final answer should be negative 5 plus and minus square root of 23, or 1 square root of 23. Okay. Fully simplified, that's what I'm going to be looking for.
Yeah, well, I made that 1.
Okay, what's 2 divided by 2? 1. Okay, what's 1 times anything? It's still that thing, right?
Oh,
so I don't really need it. I can just drop it off. Yep.
So why did you put 1? Is count wrong?
Well, unless it was in the very front. Excuse me?
Why did you put 1? Is count wrong?
No, that would be just fine. Yes?
Okay.
92 divided by 2 is 46. I'm just dividing to figure out what numbers can go into 96. Yes? Yes, sir. Okay, y'all take a moment, do this example. This one you actually cannot simplify. Here I'm telling you A is 1, B is 3, C is -7. Then you start plugging in the numbers. You've got the negative. And again, see me putting down the parentheses first because I take care of all that. Then I got 3, 3, 1, -7, and 1.
I remember doing that.
Plus and minus. You got 9 plus 28.
Square root of 37.
37 over 2. Nothing you can do about that. That's it. You're done.
So you don't divide that? Sure.
There's nothing to divide. This right here is a prime number. 37 is a prime number, so you can't divide that further. That's it. You're done.
Isn't it negative plus?
Complex zeros, or in other words, complex answers is a separate example when they're really the same thing. In other words, the book for some reason separated if you get a negative inside the square root, which I don't think is that big of a deal. It's that you got a negative. Now, in Algebra 1, if you got a negative in the square root, you would have written no real solution. In MMA, you probably still would have written no real solution, like as in, oh, you got no real answers. Well, they're right. They're not real answers. But now we know imaginary numbers. So we can actually find, let's say, non-real or complex or imaginary answers. Okay. So let's look at that, where that happens in this case. What's A, what's B, and what's C?
A is 2,
1, and 2.
Correct. 2, -1, and 2. Plug those numbers into the formula. Okay, and when you can see here, as we're doing that, how those numbers are all being put in. And notice here, I still have negative. What's negative going to become? Positive. Okay, -1 squared is?
-1.
No, +1. 4 times 2. Because A is 2 and C is 2?
Oh, yes.
So 4 times 2 is 8, times 2 again is 16. What's 1 minus 16?
Negative 15.
Okay, so that's what I'll end up on top. I'll have a +1 plus and minus the square root of -15 over 2 times 2, which is 4. Okay, at this point, this is where you would try to simplify. Okay, can you simplify 15? It's just 5 and 3. So are there any pairs? No, there's no pairs. But the negative. Every time I see a negative in the square root, based on, say, Friday or the last section, put an I. So you should have 1 plus and minus I square root of 15. That I represents the negative, and that's it. You're done.
So you don't need the negative inside, you just put the
Yes.
I outside.
All right, so let's look at the discriminant. The discriminant would be, it's part of the quadratic formula, and it helps you determine what type of roots and how many roots you have. In other words, how many answers and what kind of answers you have. Now, the discriminant is just the b squared minus 4ac part. It's just the part that you find under the square root. So if you look at this, the b squared minus 4ac, if b squared minus 4ac, when you do that part and you get a positive number, a number bigger than 0, that means your graph actually crosses the x-axis twice, and you would actually see that on your calculator. And that means you have 2 real solutions. If it's equal to 0, then you'll have 1 real solution. And if it's less than 0, you have 2 non-real complex solutions. So what we're saying here is there's 3 possibilities. If you have a positive number, 2 real answers. Equal to 0, 1 real answer, which actually counts twice, but we'll just say 1 real answer. If it's a negative number, then that means we're going to say 2 non-real solutions, or 2 imaginary solutions. And that's it. Test questions will usually go, here's an equation, give me the discriminant and the number and type of solutions. Let's look at an example. X squared minus 6x equals -7. Again, to do this, you always need to have it in the same format of equal to 0. Is it equal to 0?
So it's plus 7.
So you're going to make it plus 7. So move the 7 back over to the other side. Everything has to be on the side of the x squared.
Is that big this one?
It was.
Or
All right. What's A, what's B, what's C?
1, negative 6, and 7.
1, negative 6, and 7. Plug that into the b squared minus 4ac formula. So you'd end up with negative 6 squared minus 4 times 1 times 7. What do you get for an answer? When you type in those numbers into a calculator, if you'd like, what would you get for an answer?
A number.
Thank you for that, say, astute observation.
You're welcome, sir.
Wait, sir, wait.
So you get 8.
You would get 8. 8, that's your discriminant. When I ask for a discriminant, it's that answer, 8. Now, since that is a positive number, what does that mean? Do I have 2 real, 1 real, or 2 non-real?
2 real.
2 real. Since it's positive, correct. You have 2 real solutions. There you go.
Even though there's only one number?
There's only one number. But if you were to graph that, you would see it. It would cross the x-axis twice.
Yeah.
That's what that means.
So
You can tell that just by what type of number you've got.
So that's the answer.
All right. Another example, x squared minus 6x equals negative 11, which would make that plus 11. Plug that in. Plug that into the formula. What do you get when you say negative 6 squared minus 4 times 1 times 11?
That's another example.
Yes. What would the discriminant be for this one?
Let's see.
Wait, sir.
So negative 8, and it should be, that's your discriminant, and that means you have 2 non-real answers, solutions. And usually I just like take 2 real, 2 non-real. It would be equal to 0.
Always.
Always. Of course. So your assignment is from the Project B workbook, page 36. All of that, it's only like, say, 10 problems, so there you go.
The workbook.
The workbook.